Imagine you're floating through space, surrounded by stars, and you spot a massive dark void ahead. You've found a black hole. At first, it just looks like a patch of empty sky. But as you drift closer, you notice the stars around it begin to warp and stretch. Space itself is being distorted. You're falling in. So, what happens next? First, let's understand what a black hole really is. A black hole is a region of space-time where gravity is so strong that nothing, not even light, can escape its pull. Most black holes are formed when massive stars collapse under their own gravity at the end of their lives. This collapse compresses the star's core into an incredibly small space, forming a singularity, a point of infinite density surrounded by the event horizon. The event horizon is the boundary around the black hole. Cross it and there's no turning back. As you approach the black hole, you'd start to feel the effects of what's known as gravitational time dilation. According to Einstein's theory of general relativity, gravity slows down time. The stronger the gravity, the slower time moves. From your perspective, everything feels normal. But to an outside observer, you're slowing down. And eventually, you'd appear frozen at the edge of the event horizon, your image stretching and reddening due to a phenomenon called gravitational redshift. But you don't notice any of that, you're falling in. And here's where things start to get weird. Let's say the black hole is small, maybe a few times the mass of our sun. As you fall in feet first, the difference in gravitational pull between your head and your toes becomes extreme. This is called tidal force. Your body would stretch vertically and compress horizontally. Scientists call this process spaghettification. You would literally be pulled into a long, thin strand of atoms. It's a quick and fatal process. Within moments, your body would be torn apart at the atomic level. But what if the black hole is supermassive, like the ones at the centers of galaxies? In that case, something very different happens. A supermassive black hole, millions or even billions of times more massive than the Sun, has a much gentler gradient of gravitational force at its event horizon. The tidal forces are weaker there, so you might actually cross the event horizon without even noticing. There'd be no immediate pain or stretching. You'd be floating in what seems like empty space. But you're trapped. Every possible path now leads inward, toward the singularity. Inside, physics as we know it starts to break down. The laws that govern space, time, and matter stop making sense near the singularity. Current theories, including general relativity and quantum mechanics, can't fully explain what happens at this point. But if we go by relativity alone, you'd be doomed to fall ever inward, crushed to infinite density in an infinitesimally small space. From your point of view, you'd hit the singularity in seconds. But from an outside observer's point of view, you never actually make it. You appear to freeze at the event horizon, your light redshifted into nothingness. But there's another twist. What if black holes aren't just cosmic graveyards, but cosmic portals? There are some theoretical models, extremely speculative, but mathematically consistent, that suggest black holes could connect to white holes, the reverse of black holes, which expel matter instead of pulling it in. Together, this forms a kind of tunnel called a wormhole. You've seen it in science fiction, instant shortcuts between distant points in space or even time. But this is purely hypothetical. Any such tunnel would be wildly unstable. Any matter entering would collapse it instantly, at least with our current understanding of physics. Still, it's one of the reasons black holes are so fascinating. They might just hold the key to understanding how the universe is woven together. Now, here's something even more mind-blowing. When matter falls into a black hole, where does it go? According to classical physics, it's lost forever. But quantum physics disagrees. Quantum theory says information cannot be destroyed. This leads to what's known as the black hole information paradox. Some scientists believe that information is somehow encoded in the event horizon, or perhaps released slowly over time through Hawking radiation, a theoretical form of energy predicted by physicist Stephen Hawking. Hawking radiation suggests that black holes evaporate slowly over vast timescales, leaking energy and potentially information back into the universe. If true, then even black holes die. Eventually. So what's the final answer? What happens if you fall into a black hole? If it's small, you die quickly ripped apart by tidal forces. If it's large, you might fall through the event horizon without feeling anything. drifting toward an end you can't see or comprehend. You're lost to the universe, trapped in a region where time and space fold in on themselves. But maybe not definitely, but maybe your information isn't gone. Maybe, somehow, it echoes on the surface of the event horizon, or even leaks back out over billions of years. Maybe black holes aren't the end, but the start of something else entirely. Until we have a unified theory of quantum gravity, we can't know for sure. But black holes remain one of the greatest mysteries in all of physics. A window into the most extreme mind-bending places in our universe. And if you ever do fall into one, well, at least you'll be part of the mystery forever.